In this video, our colleague demonstrates a full workflow in the Siemens platform focused on automated part costing. This user story demonstrates the technical capabilities of this platform to provide more transparency, enabling you to identify cost drivers to make better informed decisions. This optimizes product design for cost efficiency while maintaining quality and profitability. Let's get started.
Hi, my name is Patrick Jonak. I'm a computer scientist with CCAT, and today I'm going to be walking you through a costing workflow using Siemens PCM, or Product Costing Management. So first thing, we need to go into NXCAM and export an Excel file which will hold the metadata for the part that we want to cost. And the simple way to do it is to open the part within NXCAM, right-click on the navigation tab and click Export to Spreadsheet. Now, once you have that file ready, you can open it within Excel. And within Excel, you want to identify 3 columns which are important, which is description, time, and tool number. So the time is the cycle time of each operation. Description is the operation name. The tool number is important because if a specific operation has no tool number, it's not really an operation, so therefore we don't want to count it. So we want to filter by that tool number when we're importing the data. Don't save. Now we can go back to the second Excel file, which is a template that I created. And this file will help us format that data into the correct structure for ingestion into PCM. And we can go to the Wizard tab. And this tab will help us configure the file so that it formats the data correctly for import into PCM. So the first thing that we need is the source file. The source file is the file that we're importing the data from. Now, I have the path for that file here. I saved it earlier. So I can take it here and paste it in. You would need to do this just by going to File in its location within your directory, right-click on it, click on Properties, then you will copy the location, add on the file name, and then the file extension. Well, I did that ahead of time. So now we can close this out. So the next thing they need to set is the item number. So the item number is important because it's the only way that you can identify a part within PCM. It's like its unique identifier. So we need to make sure that it's unique and that there isn't any repetition, because then PCM will have a conflict, won't know which part to pull. So because I haven't created a part before, I'm going to just call it 001. Then the title is the name of the part. And you can name it something descriptive so you know what you're looking at. I'm going to call it test part. And then I'm going to say the location where I'm going to make this part, so Connecticut, and then the machine I'm going to be running on, which is DMG. So now that's set. The next thing we need to configure is the region. So I have 2 pre-programmed options here. I have Connecticut and I have Texas. So for this part, I'm going to stick with Connecticut. Then the next configuration we need to set is the quantity. So the quantity is how many pieces you're going to do at a time during an operation. So if you're doing batch flow and you have multiple pieces being processed at the same time, you would set this to whatever the size of the batch is. But we're going to assume single piece flow, so we're going to keep it to 1. Then we have annual requirement. So this is how many pieces you need to make in a year. This is probably set by your LTA with a customer. So if you have, an agreement for 1,000 parts per year, this is where you put the 1,000 parts in. Number of manufacturing lots. So this is how many lots you're going to produce over the 1,000 parts. Then you have lifetime, which is how many years are you going to be producing these parts for. So in this case, I'm going to say 3 years. Then finally, you have machine number, which is just the model of the machine you're going to be running on. We're going to assume this control part is going to be made on DMG. So we're going to say LaserTech 65 3D hybrid. Then number of laborers is 1, and then the number of tended systems is 1. So we're assuming there's just one machine operator on one machine producing the part. So once we're happy with this configuration, we can just go to the Data tab, and then we can click Refresh All. So once we have refreshed all the queries, we should have the correctly formatted tables. So I'm going to walk through them really quickly just to show you what's in them. So the first table we have here is the part view. And this holds like the high level information about the part. So we have item number, title, the region, the quantity per batch, etc., like we did set in the configuration. The only new information here that's being added is the quantity units, which is going to be in pieces. Currency is US dollars. The BOM level is going to be 0 because this is the top level of the BOM. It's a part, and then we're going to set 2 configuration options for PCM, which is procurement type. That's a purchase. So the stock material isn't made by us, it's being purchased by us. And then the benchmark is the calculation quality. So PCM knows how to estimate the cost. Then the next table we have here is detail view. The detail view, it holds a couple important pieces of information. Firstly, it's going to hold the operation name. I also added an index, so I know the order of operations. Then we have some information that was already included in the part table. The important information here, though, is the cycle time in the units. So I converted the cycle time when I was formatting the data from the format it was in NX CAM to seconds, and I also added the units, so PCM knows what time frame it is. Then the next table we have is the B view. B view holds the labor information. So we have the same as with detail view, the operations and their order. We have some general information like the BOM level, the pieces, the US dollar for currency. And then the important information is being added here is the labor qualification. So this is an internal identifier within PCM, the labor name, and then number of laborers and the number of tended systems. Then we have the M view for machines. This is going to hold all the information concerning the machine. So again, you have your operations, your order of operations, your BOM level, quantity units, currency, line type is going to be M, and then machine is just the model of the machine. And finally, we get to the combined view, which takes all those previous tables, combines them together into a single table. And this is what we're going to use to import into PCM. So what I basically did is I combined all those tables and then reordered them using the index, so the order of operation, so I know which operation goes where. And once it's reordered, it's basically good to go. So we can hit save. We can go to save as, this PC, choose the correct location for this, go to import, and then I can give it a meaningful name. So dash Connecticut TNG, and part number is going to be 001. And I hit save. So once we've saved the file, we can just exit out. So once you're in PCM and you've logged in, on the left-hand side you have a directory or Explorer. You need to go into private folder and then find your user. And then the next thing you can do is click import, export, and then find import BOM from spreadsheet. And this will open an import configuration screen. And I've created an import ahead of time, but I'm going to walk you through it. The import that I'm interested in is CCAT NC toolpath import with machine. So you will need to recreate this on your own when you're costing your part for the first time. So I can hit next. The first thing it's going to ask me is the file that I want to import from. So I can go to Browse PC, then select Connecticut DMG 1, hit open. The locale is English United States. File type is Excel, so I can leave that as it is. Then it's going to ask me which table to import from. So I know it's going to be the combined view table, so I can select that, hit next. Then it's going to ask me to match internal data types to the designation that I have within the spreadsheet, and the designation is the same, so there's nothing that I need to do here. So I can hit next. And this is the important screen. So this is where I map the data from the spreadsheet to the data within PCM. So what you really care about here is the field name and then the column name. The column name is the name of the column within the spreadsheet. So you need to map it to the correct field within PCM. Now, I did this ahead of time, so these field names were pre-selected by me. They might not match to what you see when you first set up this configuration template, but the way to add the correct field names is to go into Manage Columns. And on the left here, you have a list of fields within PCM, so you need to select the ones you care about. So I recommend you just look at which fields are within this configuration and just find them within this field selection pop-up. Once you found the correct field, you can click on it. So for example, I can see carbon footprint here. If I wanted to add carbon footprint into my configuration, I would just click on it and then hit this arrow button, and then should import it into the selected or the right-hand side. And then all I would have to do is click OK. But because I set this up ahead of time, I don't need to do that. And I hit Next. On this screen, there are two important things to note. In the lookup options, you have this lookup parts and material master. So for example, if we had a complex part with multiple BOM levels with subassemblies, we would want to look up the subassemblies, assuming we've costed them before within PCM. This is where the part number would come in, and it's important because that part number is how PCM would look up the part. So within your BOM, you would have to include the same part number, and then it will find it for you. Then the second one that we're interested in here is the lookup machines and assets. So the machine model maps to a model within PCM, and that's how it's going to be able to pull the correct costs. So we want to select this option. So finally, we have the structure import, and this is where we can see how the individual tables map to data within PCM. So we have identifiers here for the tables. For example, we have part, we have detail, we have B, and we have M. And we can see what those stand for. So B is labor, M is machine, detail is detailed manufacturing step, part is part. So that's where those tables are going. We hit Next. And here we just want to click no update of existing data so we don't overwrite anything. And we're finally ready to complete the import. So if everything looks okay to you, you can hit execute. It's going to ask you, do you want to save the configuration? Click yes. And it says it's successfully executed, so we can exit. So now if we expand my user profile, I will see this part nested under my name in the directory. So now I can double click on this part, and it will open it up for me. Now, the final step here before we can calculate the price is to define a stock material. So if we go to the Materials tab and I click on the New button, I can select Standard. And this will let me to define my stock material. So first thing we need to do is go here and select Calculated for net weight. And then for deployed weight, we can say Detailed Input. Then we can, in this new Geometry Calculator box, we can select Cuboid. And we can select the units. Our units are going to be inches, so we're going to say the width is 8, height is 2 inches, and then the depth is 12. And I can hit accept. So now we'll calculate the volume for me based on those dimensions. Next thing I need to do is select the substance. So what is the stock material made of? So I know our material is going to be an aluminum alloy 6061, so I can hit search within PCM. And it will find it for me. I can hit accept. So now that I have the material, it knows the density, so it calculated the weight for me. So the next thing I need to do is define the scrap rate. So I'm going to say it's a fairly big stock material. We're going to have a little bit of waste, so we're going to say 20% of it is scrap. And finally, the last two things we need to do is add the price per ton for both the stock material and the scrap. So I did that ahead of time. So if I go here to cost and workflow, import, have stock pricing, and I did this calculation. So the stock material costs $117 per piece, which works out to be about $14,000 per ton. So I can copy that. Go here, paste it in. And the next thing we need to paste in is the cost of the stock, or sorry, the scrap material, which is roughly $1,200 per ton. And I want to clarify, these are metric tons, not short tons. Another important note is when you're adding the scrap cost, it should be negative because you're selling it back, so it's taking away from the cost of the price or of the part. Hit accept. So now we've added the cost of the stock material. So the only thing that's left is to go to calculation, and it will give us the final cost of the part. So we'll break it down for us by raw material, which is 115, and then manufacturing cost, which is $37. Now, for comparison, I can redo this exact same thing, but with different configuration. So if I go back here, I created a second PCM import with a slightly different configuration. I can just show you that now. So this is the exact same part, exact same operations. The only difference is I've selected Texas as the region, and then I've selected the Haas mini mill as the machine that we're going to be creating this part on. Everything else is the same, so I can hit save. Just to be sure, I can go back here, content, and then refresh, so I know that all the data is current. And then I can hit save again. Then I can exit out of this, close this out. So I can go through exactly the same process. So I'm gonna just do this really quickly. I'm not gonna go through all the steps in detail. Just make sure I'm selecting the correct file. So I'm gonna do Texas Haas, Excel. Next. Next. And finally, we can hit execute, save the configuration, yes. It's initializing the operation, so it should be uploaded in a second. We can hit exit. Now we can open that as well. So once we have the part imported into PCM, we can go through exactly the same steps as before. We need to define a material, so we can hit new, select standard. And I'm going to go through this really quickly since we did this before. Go to detailed input, 3D objects, cuboid, change the units to inches, go depth is 8, height is 2, depth is 12. Hit enter. Accept. Now once we have the dimensions, select substance. Search. Accept. So now the final step is just to add the costs. So 14,000 for stock material. And then if we go to scrap cost per ton, it's 1,200. And remember to add the negative before. And once we've done that, we can hit accept. The cost has been added. And now we have the final calculation. So we have raw material price, 117.89, should be the same as before. And now the manufacturing costs are $34. So the total works out to be 152. So now we can do a little comparison. I'm going to right click on the tab at the top and select new horizontal tab group. I can scroll to the bottom. Here we have the comparison. $153.22 for Connecticut on a DMG and $152.22 for the Haas mini mill in Texas. So not a huge difference there. So the big time savings here are from the Excel file. It's going to require some manual setup on your part, but once you have this configuration set up and you have the Excel file set up, it's literally just a matter of 2 minutes to configure the Excel file and then import it into PCM. So the neat part about this is that the Excel file links back to the initial export from NX Cam, and that file updates automatically with your paths within the NXCAM file. So if you were to edit the G code and modify how the paths are, that change will be reflected almost automatically within your import. So it's just a matter of like a minute or two to import that information back into PCM. And then you can see how that change to your program affects the costs. So you can have multiple different versions of the same part with different operations, and then you can see, okay, how do these operations affect the bottom line of my business? So if I made this optimization, how much money potentially could I save? And it's a very simple, very quick process once it's set up. This is our guide to PCM. I'm Patrick Jonak, computer scientist with CCAT. Hope you learned a lot. And for everyone at CCAT, have a good one.